Today's lecture is going to be about the first half of the chapter about retrieval and memory distortion. So let's talk about the ideas behind why we forget as well as how. And so there are two avenues that we have for studying and thinking about long-term memory. So we have recognition and we have recall. So recognition tends to be easier than recall. So we can think of this as it's typically easier to take a test that's fully multiple choice versus a test that's fully short answer questions. And this is because with the multiple choice, all you have to do is recognize the correct answer out of a series of different options. Whereas with the short answer questions, you are having to recall all of the pertinent information regarding that question. And so there are factors that are involved in the processes of encoding, storage, and retrieval. We have talked at length in the last chapter on working memory about the factors that influence the process of encoding. But what about the factors that might influence our storage and retrieval abilities? So going back to Hermann Ebbinghaus yet again, and I know that he has come up several times in this course so far because of his really landmark status as the first person to really systematically study the process of memory. He was the first one to really take the scientific method to the problem of how does memory work. And so just as a refresher, he used three-letter nonsense words. So these were words that actually didn't exist to test memory and to control for the possible influence of word meaning. So he was really just trying to make sure that the meaning of words wasn't playing a role in the memory. And remember that he had a sample size of 1 himself. And based on his rigorous testing of his own memory, he came up with a measurement for memory that came to be called percent savings, or the method of savings. And so this is a measure of the degree of forgetting that had occurred over time. So for example, it might take him 10 minutes to memorize a list of nonsense words perfectly. He would let 48 hours pass, and then he would tell himself, okay, time to recall the list. Obviously, forgetting would occur during this time, and only some of the items would be remembered. Ebbinghaus would then look back at the original list and then re-memorize it again until he knew it perfectly. So he was re-practicing. So let's say that this might take 7 minutes or so for him to relearn not only the words he already knew on the list, but the words that he had forgotten. So he found that he always spent less time rememorizing the list. So whenever he would go back and work on rememorizing the list, he realized, wow, it takes me less time to essentially review this information and sort of re-add it to my memory than when I had to first learn it. And so said another way, there were some savings from the earlier experience of 48 hours before. So essentially, there was this efficiency that he found. And the percent savings was his measure of memory. So the difference between not only how long it took him to relearn the words in comparison to the very first time he learned the words, but also the amount difference that he found when he would relearn and relearn and relearn. He found, oh, I am retaining more and more. And so essentially, he found that the higher the percentage of savings, the more items he remembered. Or another way of thinking about this is he forgot less. And then Ebbinghaus could remember the list in less time. And so some researchers by the name of Baric, and Whitlinger, they conducted a more real life study, looking at, well, what happens when we have to actually remember information that is meaningful, because that's often far more the case in real life than having to remember information that doesn't have any meaning to it. And so they conducted a study where they tested people's memory for the names and faces of their high school classmates. And they found that after about 15 years, people could identify pictures of people and also match names to the pictures with about 90% accuracy. And so again, keep in mind that this is retrieval of information in a way that is recognizing the information. So you are shown a series of options, and then you are choosing from them which one you believe to be accurate. So we have 90% accuracy for recognition, and then free recall of the names. They found when they caught up with these folks later, about 50 years afterward, they found that being able to freely recall the names of classmates had dropped by 60%. So there's this big drop off that seems to accompany the passage of time. And then one of the Barics, I don't know if it was the first or the second Baric in that 1975 article, but one of them then went on to conduct a study on the retention of high school Spanish over the span of 50 years. And so these studies, they both showed this sort of similar pattern of memory. And so it led one of the Barics to suggest that there is this sort of 3-stage period of information transition that leads to eventually a relatively permanent memory, but there is quite a loss of information that happens as well. So there's sort of this initial decline, this initial drop off, then a long plateau where you know, our memories still remain pretty stable for a certain event or facts, you know, people, events. And then after a while, then there's a sort of final decline. And so a researcher by the name of Neisser pushed back against this idea and said, well, I don't think there's necessarily like this sort of initial decline, plateau, and then final decline. And then, oh, you know, that after the final decline, this memory or this information is permanently in your information perfectly. This is like the final stage of memory. But rather, Neisser was like, well, actually, I think that some memories actually come to a point where they're more resistant to being interfered. They're resistant to this sort of interference. So it's not necessarily that once they get past the final decline that's it, you know, they're captured in your memory forever. But really there's some sort of other process or set of processes that are influencing our memory. And it's not necessarily just having to do with the passage of time. Which is what Baric kind of came to. So this debate then begs the question, are our memories really static and therefore open to possible decay? You know, are they sort of these snapshots in time and then eventually some of the pieces start to fade? Or are our memories representations that become reorganized in the recall process? So you might remember when we talked about flashbulb memories, and some of the research coming out of those has shown that even with flashbulb memories, right, which are really vivid, really have staying power with you, are highly emotional, highly personal, the more that people have to recall that information, the more likely they are to add new details, leave out details, and not that they are intentionally lying, but it just suggests that, well, maybe there is this reconstruction of memory that happens every time we go to retrieve it. So it's not necessarily like, pulling a picture out of the drawer and saying, oh yeah, this is what I remember. But rather you have these different pieces that you pull out of the drawer and have to reassemble every time you try to remember something. So let's talk about some of the factors that influence storage. So the nature of forgetting in long-term memory has been a bit of a debate. So actually a behavior theorist, Thorndike in 1914, he proposed what he called his law of disuse. The idea that our habits or memories are used repeatedly, and that these are the ones that become strengthened, but the habits that are not used are weakened. So essentially, this idea of use it or lose it, right? So if you aren't continuing to go back to a memory, it's going to fade away. However, if you do continue to go back to it, it'll become strengthened, so to speak, and it will continue to remain available to you. However, what the evidence suggests is that it's actually not purely decay. It's not this idea of, well, passage of time is just a naturally occurring part of life, and if you're able to use all of the things that you've retained, then you continue to retain them. But it's actually more nuanced than that, and it actually seems like interference or a loss of access can have more of an impact on our experience of forgetting, rather than this just more simple, basic decay principle. So for instance, some researchers in 1924, they had their participants learn some information, after which half of them went to sleep and then the other half had to stay awake. If I was in the study, I would be really annoyed if I had been randomly assigned to the half that had to stay awake. I could have slept this whole time. That's just me. But anyway, what the researchers found is that the participants who slept, they remembered the material better than those who stayed awake. Now, this challenged the idea of decay, because if decay, aka the simple passage of time, use it or lose it, if decay was what was causing this information to be lost to participants' access, then we should have seen the same memory loss, the same amount of memory loss across both of these groups, right? Passage of time, regardless of what they were doing, happened to both equally. But because the participants who had stayed awake were actually less able to recall the information that they had learned, this suggested, well, there must be some sort of interference influence that can happen, right? And this is because it was thought that, well, the half of the participants who fell asleep, there was nothing that was interfering with their memory of the information that they had learned. However, the participants who stayed awake, they continued to take in new information. They didn't have to continue to learn new information, but just as a byproduct of continuing to be alive and conscious, they continued to encounter new information in the world. And so perhaps this created some sort of interference that made these participants who didn't fall asleep have more difficulty and to lose more information. I also just will point out too that this is just one study of many that points to the importance of sleep when it comes to memory. And this is because research has shown us that the consolidation or the stabilizing of our memories in our long-term memory stores happens when we sleep. So to those of you who are pulling all-nighters and cramming information in your brain, keep in mind that it actually is more beneficial for you to get some sleep. so that that information can actually stick, quote unquote. Okay, that's just my soapbox for college students to have more sleep. And I say that both as somebody who has looked at the research, but also somebody who was a college student and didn't sleep very much and is also currently a graduate student and also doesn't sleep very much. So anyway, let's move on to talk about another factor that can happen in the storage process. And so this is when consolidation is disrupted. And so again, consolidation, it requires time. Oh, that's a typo on the slide. It should say requires time. Requires time in order for information to be stabilized. So really have to just be patient with ourselves because we just need time for that information to really settle in. And so, of course, as we've talked about, right, there's this neural activity that's going on, that's transferring information from the short term to the long term, and this eventually results in consolidation. And so there is evidence that the consolidation process can be impaired if there is damage to the hippocampus or even some of its surrounding regions that the hippocampus is heavily involved in. And of course, you might remember that we've talked about HM, who had surgical removal. It was experimental at the time. They didn't actually know what was going to happen. But he had surgical removal of both of his hippocampi, that is right and left hippocampi. And so, and although that this helped treat his really severe epilepsy, it really helped control the frequency and severity of his seizures. He obviously was left with a range of memory problems. And so his short-term memory continued to function, but his long-term memory was essentially no longer there. And so the main problem that researchers found HM to experience was this inability to remember and learn new things. So you might remember the more technical word for this is anterograde amnesia. So this inability to create new memories. And so there's been some research that, there's been a lot of research that suggests that the process of consolidation, it takes place over actually several points of time. You might remember Duday's 2004 theory about there being two stages of consolidation, where sort of the first stage or phase happens over a series of minutes and hours. And then there's also a second wave of consolidation that happens in the days and years following an event or an instance of learning. And then, of course, consolidation can also be disrupted not only by hippocampal damage, like in the case of HM, but just the sort of neurodegenerative processes that happen from aging. We know that as we age, typically without the interference of any sort of brain damage or certain diseases, that our brains just overall, they have what's called atrophy. They shrink. They start to lose some of their volume and mass. And this is just a natural result of aging that can also then disrupt our consolidation abilities because we're starting to lose those neural connections. We're losing those synapses that once were so active. So we've talked about some storage factors. Now let's talk about some of the factors that influence retrieval. So one of these is interference. And I know that we just talked about interference in the context of storage, but it can also take place when we're trying to retrieve information as well. And so this is because the items that are in long-term memory, particularly similar items, can conflict with each other under certain conditions. And so interference is proposed to take place in two different ways. So we have proactive interference and retroactive interference. And so proactive interference, and you can think of this as pro meaning forward, this occurs when you cannot learn a new task because of an old task that has been learned. So here, what we already know interferes with what we're currently learning. So this is where old memories might then disrupt new memories. Whereas retroactive interference, and again, to help differentiate between these, retro, you can think of backward, occurs when you forget a previously learned task due to the learning of a new task. And so here, in other words, later learning then interferes with earlier learning, where new memories disrupt old ones. And proactive and retroactive interference is thought to be more likely to happen when our memories are similar. So for example, maybe confusing old and new telephone numbers or something like that. So although studies of proactive and retroactive interference have shown pretty reliable and predictable effects, there are a number of problems with interference theory as just a sole explanation of why we forget. And again, this is because we've come to find out, well, there are several different factors that can have negative impacts on retrieval. So we can't just say that interference is the only thing that's happening. And so one of the reasons why interference theory is not the best as a standalone explanation of forgetting is that it doesn't tell us very much about the cognitive processes that are involved in forgetting. It seems to be rather simplistic. And also the majority of research on interference has been carried out in the lab using lists of words. And so this doesn't really transfer over into being similar to our everyday life. If you might remember from experimental psychology class, this is something that we call ecological validity. So ecological validity is the idea that what is happening in the lab is pretty synonymous, it's pretty close to what's actually happening in day-to-day life. And so with a lot of these list learning interference tasks in the lab, there's pretty low ecological validity. I think especially with the advent of having smartphones, we're not having to learn lists. We're able to just write them down and carry them with us. And so again, this doesn't really show us the nuances of day-to-day life. So that is to say that, interference is important, but we're going to talk about some other factors that can play a role in forgetting. And so there's another idea called cue competition. And so a researcher by the name of Anderson came up with this idea that if memory cues or prompts are associated or connected with more than one memory, it can actually confuse us and make recall more difficult. And so some of the assumptions underlying this idea are that different memories that are associated with a cue then become put into competition for remembering. So if there's one cue and 5 different memories may be attached with that, all 5 of those are suddenly in competition with one another when it comes to what will be retrieved. A second assumption is that remembering one memory strengthens the association or the connection to that memory and therefore weakens others. So really kind of this idea and this competitiveness of, well, there can really only be one. So even though there are 5 memories, if one of them is being recalled with more frequency, that one is going to be quote unquote the winner. And then thirdly, the very act of retrieval is a learning experience. And so again, this idea that when we retrieve information, we are not just pulling an exact replica of that memory out of our filing cabinet, but rather we are engaged in a process of reconstruction. And so the fact that we reconstruct means that that memory then becomes strengthened. It's a more active process. It's not just quite as passive as, like I said, just pulling a picture out of a drawer. And so there have been studies with word pairs where the first word of the word pair acted as a cue to participants. So for example, on the slide here, I have the word dinner. So maybe the word pairs would be dinner sushi and dinner kebab. And also comics, Black Panther, comics, Jessica Jones. And so what these studies with word pairs found when these word pairs involved sort of these multiple cues, right? The first word of the word pair was involved across different word pairs. It wasn't just dinner sushi was on its own and dinner was never repeated, but rather dinner came to be associated with other words. And so in these word pair studies, they found that the more frequently paired words strengthened the connection, and that there's also a decline in retrieval of the less frequently paired words. So for example, if participants were given a list of word pairs that included dinner sushi and dinner kebab, and let's say that they were practicing these over and over each time after they sort of quote unquote learned the word list, right? The list was read off to them. And then they were asked, you know, which word goes with dinner? And they would often respond with sushi, and then they would be told, okay, that's correct. And so even though dinner and sushi and dinner and kebab were still on the list, the reinforcement of dinner being connected to sushi meant that dinner then became the cue connected best to sushi, such that the kebab connection to dinner was weakened. And so again, there's this competition between the memories that were associated with these cues that comes from these cues being connected to several different things, rather than, well, dinner only being connected to sushi and lamb only being connected to kebab, or something like that. So another factor in retrieval that has to do with cues actually is called this idea of cue diffusion. And one of the assumptions that cognitive models that are about how we make meaning and how meaning is then represented in the mind, they talk about the activation of memory representation as being this limited resource. And so again, sort of this idea that our cognitive abilities are limited in terms of their resources, in terms of their energy. And so the idea here is that if a cue has a lot of different associations, the activation then will spread out among the many paths that are associated with that. So essentially, a strong activation gets, or a strong association, pardon me, gets more activation, whereas a weak association gets less. And so it's thought of that there's this limited amount of energy to activate this network of associations. And so if we look here at this picture that's on the slide, which I'll talk a little bit more in depth as well, but if we look here, I mean, if we start with the idea of fire engine, right? We see that fire engine has a lot more connections to it. You know, you have red fire, house, ambulance, truck, all of those different ones. Whereas maybe a word like red, if you were just to think of the word red, right? Maybe only cherries, apples, pears, like maybe those would be only the associations that you have. And so the concept then of fire truck would require more energy because of its higher amount of association. And so there's a phenomenon that Anderson found and came to call the fan effect. And so this is a concept that it connects this idea of this limited energy and the activation between connections of concepts in the mind. And specifically posits that, well, the more associations that we have, actually, we not only require more energy, but we also have a longer processing time because we have to go through all of those different connections. And this then raises the probability that we're going to make errors. And so this idea of a fan in fan effect, it refers to a concept, multiple associations, which form a sort of fan. They sort of fan out from the word. So again, looking at this picture, we see that fire engine, there are a lot of different concepts that fan out or spread out from it. And there's this idea that thinking of one concept has this sort of spreading activation. So this activation that occurs along these association routes away from the initial concept. And so how Anderson studied this and then eventually came to develop this fan effect idea is that he had participants memorize 26 sentences. And then he later asked the participants to identify if certain sentences were part of the original sentences that they were asked to memorize. And so his findings showed that it was a lot harder for participants to differentiate between concepts that had multiple associations to them. So for instance, if the series of phrases bat and ball, yellow and black, and green apple are easier to remember in comparison to ball and axe, axe and call, ball and call. So here, it usually takes more time to remember the differences because there are more similar details. So there are more associations. And so the resulting confusion tends to lead to longer processing time and also the higher probability of committing errors. So another factor is called occlusion. And so this is the idea that there's this dominance of one memory that then makes the other memories or items that you're trying to recall temporarily unavailable. And so this is really quite frequently seen in the tip of the tongue phenomenon. This is where you have, again, this temporary loss of access to what you're trying to recall. This happens to us when we're telling someone and you're like, oh, you know, it was the other day when we went to, what was the name, that coffee shop, you know, the one where they have the red chairs outside. And yeah, and we got that really good parking spot. What was the name of it? It's right there. And some researchers did actually they conducted a study where they tried to induce tip of the tongue, and they did this by reading off to them definitions of words that were like a lot more obscure. And so in some of these cases, people were then experiencing tip of the tongue. They're like, oh, what's the name of that? I know what it is. Just, I can't think of what it's called. And so because, you know, they were having trouble with this, the researchers were recording kind of the process that people went through. So they were able to find out what the participants did know about the word that they were trying to access. So, someone being like, oh, I know it begins with a C, architects use it. You put your pencil in it and you can draw perfect circles. And then eventually they might say, oh, a compass. Yeah, that's right. Oh, I haven't used a compass since, I did geometry. So gosh, yeah, that was I was in there, but it was very deep. And so like I kind of just showed right then, they did discover that people were often able to identify the sound that the word started with. Maybe it's like approximate length. They might say, oh, it's kind of long, or oh, it's really short. I think it's just like 1 or 2 syllables, like it's really short. And they were mostly accurate in this information. So it wasn't such that everything about that memory was completely inaccessible to them, but rather just the word that they needed to name that that item. And they could usually talk about all the other things around it. And finally, there are the factors of suppression and repression that can interfere in retrieval. And so these are sometimes described as falling under the umbrella term of what we would call motivated forgetting. So rather than inadvertently forgetting information, either because it's been interfered with, it's currently just on the tip of our tongue and we're consciously and actively trying to recall it. In the cases of suppression and repression, there's motivation for us actually to forget. We're actually wanting to try to forget. And so suppression is actually a useful psychological mechanism. And with suppression, we're pushing unwanted information out of our awareness or our focus. We're consciously choosing to not think about something, a feeling, an action, a conversation, even though we are aware of it. And so this helps us to sort of regulate our behavior in terms of not being distracted by like impulses, but also we can be like, no, like that, that memory is too painful. I don't want to think about that right now. I'm just gonna focus on something else. I'm gonna push that away and not think about, the way that I handled that situation, or like how I'm currently feeling. Maybe I'm really sad and I'm just like, nope, can't go there. I'm gonna push it away. So in comparison, so repression is somewhat similar to suppression. And I know it doesn't help that they have very similar sounding names. But repression is similar to suppression, but it involves unconsciously forgetting or blocking out those unpleasant thoughts or feelings or impulses. And so this is often what happens with people who have had trauma. So people who have experienced something traumatic quite often unconsciously push away the really disturbing memories and feelings that came out of that trauma. And so here, with repression, they're not thinking, oh yeah, that was horrible to be in that car accident and to see all that blood and whatever. I'm gonna push it away. I can't think about that. They actually don't have control over that. Repression is actually something that happens outside of their control. It happens unconsciously. And so, like I said, these aren't really like forgetting in sort of the other ways that we've been talking about. And again, there's this idea of there being a particular motivation to forget in the instances of suppression and repression. Whereas, we're with other information, we are not trying either consciously or unconsciously to forget information. And so like normally forgotten information can usually be recalled with some sort of trigger or maybe a cue. So maybe earlier in the day you were planning to call the doctor to make an appointment and you got distracted and you forgot. And then later you hear a phone ring and that might sort of trigger you or cue you to be like, oh my gosh, I need to call the doctor. And so again, these are suppression and repression. They are a really kind of special subset of forgetting. And of course, as you can imagine, suppression and repression, they interfere with our conscious encoding process, which then of course has consequences for retrieval. And so, for example, with suppression, right? If we are consciously pushing information out of awareness, we are not going to be encoding it in the same way that we would as if we were like, okay, you know what, like I'm really going to like think about this, and play it through the way it happened, or I'm currently feeling sad, and instead of pushing that away, like I'm gonna sit with it, I'm gonna reflect on it, I'm gonna do some soul searching, I might even do some problem solving, to figure out, okay, is this connected to something, or so we're not processing it in the same sort of way that we would with other information. And then of course, as we've learned about the process of learning and memory, right, the encoding, the storage, and the retrieval, they're all interconnected. So what happens at one level often has consequences for processes at a different level. So then of course, if there's encoding that is then interrupted in some way by either suppression or repression, this is of course then going to have consequences for our retrieval ability. And so again, because the suppressed material, it is in our conscious awareness, it's often likely that we can recall it. We can be like, oh, like, yeah, I was really trying not to think about that, but I still can, right? I still can have access to it. But on the other hand, the repressed material, this is harder to get at because it is unconscious. So it wasn't stored in a way that we remember, right? It was thrown into just sort of a random drawer, versus being put into our nice, neat, organized set of filing cabinets that are alphabetized and color coded, like thinking about the scene at the very end of the Indiana Jones movie, like Raiders of the Lost Ark. There's that scene where they're taking an artifact into like this big warehouse, and the camera zooms out, and all of a sudden you see that there are just rows and rows and rows of boxes. It would be like with repression, it would be like just taking a file folder and closing your eyes and just chucking it somewhere, being like, okay, there we go. And so that's what's going to make it a lot more difficult to find it, right? You're like, I don't even know where to start. There was so much interference with the encoding and storage process that the retrieval for this is now going to be really, really difficult. Okay, so that is the end of today's lecture. On Friday, we will finish up talking about retrieval and memory distortions. We'll be talking about some interesting information related to memory distortion, eyewitness testimony, yes, memory distortions, I just totally blanked. Memory distortions, eyewitness testimony, recovered memories. So just some really interesting sort of quote unquote real life implications for what happens when our memories are distorted in some way. So as you're continuing to study for the test, Please let me know if you have any questions, and bring any unanswered questions that you have about the study guide to our live class session on Wednesday. See you then.